So next, let us see what happens during data decapsulation on machine D, which is a receiving machine. So the packet that was generated by the machine A will be routed by the machine B, by the machine C, and let us assume that the packet eventually reaches the destination machine D. So how TCP IP stack on machine D performs data decapsulation? Let's see. So machine D picks up the data from the wire. That is, it is a data link layer which picks up the data from the wire or physical link. So you can see that the data is read as it is. So MAC header contains the MAC address of the machine C and the MAC address of the machine D. Just remember that the data link layer always works between adjacent nodes. So machine D will eventually receives the data from machine C, and therefore the MAC addresses specified in the MAC header is the MAC address of the machine C and the MAC address of the machine D. You will understand the process by virtue of which the content of the MAC header keeps on changing between adjacent machines, that is hop by hop, when we will be learning L2 routing. So anyways, once the data link layer picks up the data, it detaches its own header called MAC header and passes the rest of the message to the layer running above it, that is the network layer. The network layer does the same thing. It detaches its own header and passes the rest of the message to the layer running above it, that is the transport layer. The transport layer knows that the message has to be delivered to the application app2 running on the destination machine D. Remember that machine D is some machine which could have multiple applications running. So transport layer needs to know that out of those many applications, which application is interested in receiving this data. And therefore, it was required to encode the identity of the receiving application in the transport header by the machine A. So transport layer eventually ships or hand over the original application data to the application app2. So app2 eventually receives the data. So this is the entire cycle of data encapsulation and data decapsulation. Now let us see what happens on intermediate machine, that is the machine B and machine C. We have studied the data encapsulation process happening on machine A, which is the sending machine, and we have studied the data decapsulation process happening on the receiving machine, that is the destination machine. But the TCP IP stack of intermediate machine B and C also plays some role in forwarding the data. So let us see what happens in the TCP IP stack with respect to machine B and machine C, which are neither sending machine nor receiving machine, but they are forwarding machines.